Now that we've talked about points of concurrency in a triangle, we can look at other segments in a triangle and information we know about that. So this section is going to be about midsegments of a triangle. So let's first define what is a midsegment. A midsegment is basically a segment whose endpoints are the midpoints of opposite sides of a triangle. All right, so again, a midsegment is a segment whose endpoints are the midpoints of two sides of a triangle. So for example, if you look at this diagram on the left, excuse me, we've got three midpoints. So remember, look for the markings or look for the given information in the problem showing you we have midpoints. So remember, if two sides are if a side, is cut in half, so like these markings right here, right? They're both 1 and 1, so that means x is the midpoint of the side QP. Therefore, that makes this segment XY a midsegment because Y is also the midpoint of QR. All right. Again, that is what a midsegment is. So again, for example, XY is midsegment of triangle PQR. Looking at this diagram, you should also be able to pull out two other midsegments. Can you guess what they are? Right, they should also be XZ and YZ are also midsegments of PQR. Now, why is this midsegment important? Well, we can deal with midsegments and their corresponding sides using the midsegment theorem. So let's look at this triangle midsegment theorem. Okay, so we know two things about the midsegment of a triangle. A midsegment is parallel to one side of the triangle. Hopefully it's pretty clear which one it's parallel to. It's parallel to the side that it doesn't intersect. And in addition to that, the length of the midsegment is half the length of that parallel side. So if you take a look at the example on the left, you should be able to tell DE is a midsegment because again, it goes from midpoint to midpoint, right? So again, we know two things from this theorem. So we know if DE is a midsegment of triangle ABC, then we can say two things. First, DE should be parallel to the side it doesn't intersect, so it should be parallel to AC. And we also know that DE is 1/2 of the measure of AC, and that's the triangle midsegment theorem. And we can use that in our first example to calculate some lengths and find some angles. All right, let's look at example 1. I want to find the length of BD. So first, what can you tell me about BD? Well, notice B and D are midpoints of two sides of a triangle, so we know BD is a midsegment. So that means BD should be half of one side of that triangle. BD should be half of which side? Well, hopefully you're seeing BD should be 1/2 of AE because that's the side it's parallel to, right? And since we know AE is 17, just plug it in, and BD is equal to 17 over 2, or 8.5 units. And I don't care if you write it as the fraction or the decimal, again, as long as it's the exact answer, the fractions are completely reduced. All right? So that's the midsegment. Now, you might be looking at this and be saying, wait, Ms. Wong, how do we find angles? The midsegment didn't tell me anything about angles. Indeed, it didn't tell me anything about angles, but it told me that the midsegment is parallel to one of those sides. So BD should also be parallel to AE. Now, think carefully about what you know about parallel lines and angles from what we learned in Chapter 3, first trimester. So first, let me trace out where is angle CBD. So I'm looking for this green angle here, that's angle CBD. And you'll notice some interesting information, right? So I know this angle right here is 26 degrees. And I want to find this angle right over here. Well, BD and AE being parallel doesn't really help me too much, so I might want to look at other sides as well. So I also know that the other midsegment, DF, is parallel to AC. Remember, BD doesn't really help me here, so let's take a look at DF and AC. Well, these lines being parallel, what does that show me? Well, that shows me, wait, I've got two lines cut by transversal. I've got alternate interior angles. So we can see that angle DBD and angle FDB are alternate interior angles. All right, and it's hard to see because I've marked up that diagram so much. Remember, what you could do is you can just pull out those key pieces. So here is AC, all right, here is FD, and here's that transversal BD, right? And we know this is parallel to DF, and if this is 26 degrees, then our alternate interior angles should be congruent, right? Because we have parallel lines. So angle CBD is congruent to angle FDB, right? By your alternate interior angles theorem, therefore the measure of angle CBD is also 26 degrees. So again, like I said before in class, it's important you don't just purge your memories of everything from last trimester, but continue using that, right? Continue making links from what we learned in the past to what we're doing now, okay? So those are a couple examples of how you can use the triangle midsegment theorem to solve for angles or sides. Let's take a look at example 2. We can give, for example, context to the problem and also use triangle midsegment theorem to help us out with this. So in an A-frame support, which you might see in some buildings or structures, the distance PQ is 46 degrees. So I'm just going to go ahead and draw that in. PQ 46, or sorry, it's 46 inches, not degrees. What is the support, the length of ST if S and T are midpoints of the sides? So remember, that's important. We've got midpoints, which means S is going to cut this side in half. T is going to cut the other side in half. So what does that make ST? Well, that makes ST the midsegment. Because by drawing in PQ, I've created a triangle. So now I've got a midsegment, which then I can use the midsegment theorem to help me solve for ST. So remember, ST should equal 1/2 of PQ because that is the side it doesn't intersect. And since PQ is 46, I'm just halving 46 to get 23. All right. And that is nice. That is it. Nice and brief. Hopefully, midsegment not too difficult to see. One thing to remember: how do you know you're looking at a midsegment, or when you're dealing with midsegments, look for midpoints. And there's no point of concurrency. You're basically drawing a triangle within a triangle when you connect all three midsegments. All right, come out to class with questions, and I will see you all later.